We learn in introductory economics that market equilibrium is defined as having two conditions: the intersection of supply and demand curves combined with zero profit earned by all sellers, or at least the marginal seller, so no incentive exists to enter or exit. Comparative statics is the analysis of the differences between an initial equilibrium and the equilibrium that results when some exogenous variable, something outside the control of buyers and sellers in this market, shifts demand or supply. Suppose the weekly demand and supply of tires is described by these linear functions, where the price of tires, price of gasoline, and annual family income are the measurable determinants of the quantity demanded, and the price of tires and a cost parameter reflecting changes in materials costs are the two major variables in determining supply. If the price of gasoline is at $3 and family income is at $40,000 a year, and our materials parameter is set at 10, then these two curves collapse down to the QD equals 3,200 minus 25 times the price of tires, and the quantity supplied is equal to negative 800 plus 15 times the price of tires. Solving these equations simultaneously yields the market equilibrium, in which the price is equal to $100 per tire and the quantity sold and purchased is 700. But suppose some technological innovation lowers the material costs parameter to 9, so that quantity supplied shifts out by some 200 units at each price. The shift out in supply results in the price falling and quantity expanding as we shift down the demand curve. The price falls to 95 and the quantity demanded rises to 825. Let's consider the general case for a shift in supply. Imagine quantity demanded as a function of price and some particular demand shifter alpha, holding all others fixed, and quantity supplied as responding to shifter beta. In order to ensure that quantity demanded and quantity supplied remain equal to one another following a shift in beta, holding alpha constant, the change in quantity demanded must be equal to the change in quantity supplied, resulting from the combined effects of the shift in supply and the response of quantity supplied to the change in price needed to restore equilibrium. Our goal is to find the change in price needed to restore equilibrium. That is, we want to solve the total differential for dP. So I need to collect terms. d sub p minus s sub p dP is equal to s sub beta d beta. I'm going to multiply both sides by -1 to reverse the order. D sub p dP is equal to negative s sub beta d beta, or dP is equal to the ratio of the responsiveness of supply to the shifter over the difference between the slope of the supply curve and the slope of the demand curve multiplied by the size of the shifter, the size of the change in the shifter. So we know that S sub p is positive, and we know that the demand curves slope down, so I have a negative times a negative added to a positive means that we always know that the denominator of this expression will be positive. The numerator will have a sign opposite to that of the sign of the supply shifter. So if beta shifts out, supply, then the equilibrium price must fall. In our example, the slope of demand is negative 25 and the slope of supply is 15. A 1 unit increase in M, ceteris paribus, would reduce quantity supplied by 200 units. So, from our expression, dP will be equal to the negative of negative 200 over 15 S sub P minus the negative of 25 times d beta, or 200 over 40 times d beta. Our equation reflects the three consequences of a change in supply. The blue segment reflects the shift out in supply, the S beta term. Holding price constant, this shift would result in excess supply, so price has to fall from 100 to 95, resulting in the green increase in quantity demanded and the red decrease in quantity supplied, S sub P. All three effects, the size of the shift, the responsiveness of quantity demanded, and the responsiveness of quantity supplied, must be accounted for in measuring the comparative statics, the adjustment from one equilibrium to the next. Those three effects are hidden when we simply calculate the two different equilibria. Okay, in our example, dP is going to be equal to 5 times the difference between the new value of M, 9, minus the old value of M, the original value, 10, or negative 5. The new equilibrium price is the sum of the old price and the change in price, so 95. Plugging 95 back into the original supply function and applying the new value of M yields the new equilibrium quantity of 825. To summarize, to measure the effect on equilibrium price of either a shift in demand or a shift in supply, one solves the relevant differential to relate dP to demand or supply shifters. A positive shift in supply results in a drop in price, while a positive shift in demand results in a price increase.